Hey peeps, it's Julian here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're continuing with question 11 from Maths Paper 2 IEB 2019 Supplementary exam, and this question is another analytical geometry question. Okay, so they've given us a diagram with two circles on a pair of axes and some information about these two circles. But with question A, they've asked us to determine the coordinates of the center as well as the radius of the smaller circle, which is the circle over here. And they've told us that the equation of the circle is this. So by looking at this, we need to put it in the form of the standard circle equation, which is x plus a squared plus y plus b squared equals r squared. So this is the standard form for a circle, and we'll obviously then need to convert the equation that they've given us to the standard form. And the way we do this is by completing the square. So to do that, we then write all our x terms together. So x squared, and it will be minus 10x. I'm just going to leave a space here. You'll see why now. And we're going to add your y squared plus your 2y. I'm going to leave a space again, and we say equals minus 22. So the reason why I've left the space is because for completing the square, we do need to add the coefficients of x and y over 2 squared to both sides. So what that means is if the coefficient of, say, x is b, we then need to add b over 2 squared. So that's what we're going to have to do in the spaces. So we add, as I said, your b in this instance is 10, so it'll be 10 over 2 squared, and we do the same thing for y. So we add, the coefficient of y is 2 over 2 squared. And now what we do to the one side, we do to the other to keep the equivalence in the equation. So we also need to add 10 over 2 squared plus 2 over 2 squared. And we do this, as I said, so that we haven't changed anything. So both sides are still equal. Then I'm just going to rewrite this so it looks neater. So we left with x squared minus 10x. So 10 over 2 is 5. Squared is 25. So we add 25. Still plus the y squared plus your 2y. Again, 2 over 2 is 1. Squared is 1. So we plus 1. Equals, and then it's minus 22, and we just said we're going to have to add 25 and plus 1. Then we'll need to simplify this, because if we group these, remember adding brackets like this doesn't change the equivalence, we can further simplify by saying that must equal x minus 5 squared plus, and then it's y plus 1 squared, and then equals minus 22 plus 25 plus 1 is going to equal 4. The step is tricky, but basically what I did there was you open up your two brackets and you write down x. You keep the sign of the coefficient of x, so that's why I've got the minus over there, and you minus the square root of the last term. So there was 25, so you'll then minus the 5. You do the same thing for y. So you keep the sign, so that's the plus there, and then you add the square root of the 1, which gives you 1. And then of course you do that calculation, which you sometimes will need to use your calculator, but for this instance it's easy enough just to use 4. That's now in the standard form. So then to get that, to find out the center, we'll know that center of your circle equals, it's the coordinates of A and B from the standard formula, so A and B. So we know that that will equal minus 5 and 1. And then your radius is your r, but obviously the radius squared is what they're given us here, or what we've calculated there. So radius equals r squared, which equals 4. So therefore r should equal, we find the square roots of both sides, r equals 2, and then don't forget to say units. So your radius will equal 2 units. Okay, next question is B. Show that point C does not lie on the x-axis. So point C is over here. So it looks like it lies on the x-axis, but we're going to have to prove that it doesn't. And the way we're going to do this is by finding the coordinates of C. And if the y-coordinate of C is not equal to 0, it means that C does not lie on the x-axis. So how are we going to do this? Well, they've given us a few equations. So I am going to use this equation because we know that that point C lies on this circle. And they've told us that CD, so obviously C, will lie on this line over here with this equation. So they've given us two equations, which means we can solve for it simultaneously. I'm going to rewrite that first equation. So I'm going to say y equals, because it's positive 4x, I'm going to take it to the other side and make it negative 4x, still plus 13. This is going to be equation number 1. Equation number 2 will be this equation that they've told us. So I'll just rewrite it as x squared plus y squared minus 10x plus 2y equals negative 22. So as I said, this is going to be equation number 2. Then for simultaneous, we sub equation number 1 into equation number 2. So therefore, we've got still an x squared, but now instead of y squared, we're going to put in a bracket and sub in this part because this is what y equals to. So negative 4x plus 13, and this thing is still squared, minus 10x plus, and again we're going to sub in for y, so we're going to have negative 4x plus 13, and this equals 22. We're then going to multiply out the brackets. So first of all, I'm going to rewrite it nicely. So it's x squared plus, so because it's that bracket squared, we can rewrite it as minus 4x plus 13, and we're going to repeat it because it's squared, plus 13 minus 10x, and now plus, so I'm going to just times that 2 into each term of the bracket, so it'll be plus, so it actually becomes negative now, so let me rub out that plus, so it becomes negative 8x plus 2 times 13 is 26 equals negative 22. 2. Sorry, this needs to be a negative because over here it's negative. Okay, then carry on, still keep that x squared. Now we're going to FOIL out these two brackets, so it's the firsts, remember, times together. So negative 4x times negative 4x becomes plus 16x squared. Your inners will become, so 13 times negative 4x becomes negative 52x, and your outers will be the same thing, negative 52x, and your last, it's 13 times 16, so it's plus 169, and then still keeping the negative 10x, negative 8x. It's going to squeeze this in, plus 26 equals minus 22. Okay, so we're going to then put all your like terms together. So we know that there's an x squared, there's an x squared. We've got an x there, and just an x there, and another x there, and another x there, and then you've got your constants. So the x squared plus the 16x squared becomes 17x squared. All your like terms together, so negative 52x minus negative 52 is negative 104. X minus the 10 is a negative 114, minus the 8 is a negative 122x, and your constants added together should equal, well, 217 if you take that negative 22 to the other side, and this will all equal 0. So now we have a equation just in terms of x. Okay, now this is an equation that you could solve in your head, but you'd have to be very smart. So you can use your calculator for this, and if you don't know how to do that, with your scientific calculator, you press your mode and it gives you a few options. You select the equation, and then it gives you to add the coefficients, and you choose the x squared plus x plus a constant option equals 0. And for your a coefficient, so the coefficient of x squared, you'll put in 17. For your coefficient of x, you'll put in negative 122. And for your constant, you'll put 217. And I've done that on my calculator, and you should get two answers. So I get one answer being x equals 3,92, or x equals 3,26. So we can, and this is expected because we have, there's 2 points. Point D could also be, but now because point D is further along, we know that point D must have an x value of the higher x value. So therefore, this is the correct one for C, because remember we're solving for C. So we know that C equals 3,26. So we then, from equation 1 again, so remember equation 1 is y equals, so it's negative 4, and instead of x, we can sub in the 3,26 and plus the 13. Put that all in your calculator, and I get that y equals 0,02 units, which therefore means that C is not on the x axis, which is what they asked us to show. X axis, oops, that's a mess. Cool, so it's very close to the x-axis, but it's just above. If it's negative, if it's 0,02 units, it means it's just above this x-axis. Okay, and on to C. And they're asking us to now find the midpoint of line AB. So this question is a bit more difficult than the rest, and we need a game plan. So basically, what we know is they've told us that this line AB is the diameter, which means that if we need to find the midpoint of a diameter, which will be somewhere around here, that will be the center of the circle. And we're also going to need to make use of the perpendicular theorem, perpendicular bisector theorem, which is one of your circle laws. And what that states is that a line that is perpendicular to a chord of a circle, so they've told us that AC is, well, I'm sorry, CD is, you can see, is the chord of the circle. That's a line perpendicular to this chord, so it'll come out somewhere like that, so at 90 degrees, will pass through the center of the circle. So, and we've also got the equation for this line CD. So we have the equation for CD. We know that therefore this line, if we can calculate this, what the equation for this line that's perpendicular to CD is, we can then use that to make it equal to the equation of AB, and that will help us solve this particular problem. So we've got the equation of CD. So I'll just rewrite it as y equals, it's negative 4x plus 13. And the only important bit of information here is we need this negative 4 because that tells us the gradient of the line of CD, that one over there. Because we know, because of the perpendicular bisector theorem, that this line going through the chord is perpendicular, so we can then assume, or we can then conclude that the gradient of the perpendicular bisector, which is that line we're calling, so the gradient of the perpendicular bisector will be negative the inverse. So that would be negative the inverse of 4. So the inverse of 4 will be a quarter. So it's going to equal positive a quarter. So that's because it's perpendicular. So then therefore we can, the equation of the line will be y equals mx plus c. So we got that m is a quarter x plus c. And we also, extrapolating this line, also goes through the center of this circle at a obviously perpendicular. But we know what the center of the circle is from our previous question. So if we go back to A, we worked out that the center of the circle is negative 5 and 1, which is actually incorrect because it comes over here. So it looks like I made a mistake. So even in your paper, remember, sometimes you might see a mistake like this. So this is actually positive 5 and negative 1. And we know this because clearly the x should be a positive and the y should be a negative. So excuse me for that mistake. And we can see, because when we're reading off, it's got to be the opposite. So it's negative 5 and negative 1. And the reason why I got it wrong is because this equation up here is actually incorrect. That's supposed to be a negative, and that's supposed to be a negative. So even your expert tutors get it wrong sometimes. But so anyways, continuing on, that's the correct answer for that question. But now we need to use that fact that this point here is, as I said, 5 and -1. We can substitute that in, so it's going to be -y should equal 1/4 of 5 plus c. Put the c to the other side, we'll keep it there, and we have -1. That not quarter becomes a -1/4 times by 5. And if you put that into your calculator, you should get -9/4. Cool, so that's for C. So now we have the equation of this line here, which is y equals 1/4 x minus 9/4. And we have the equation of AB, which is up here. If we write that in terms of y, we get that. So it will be 3y equals -4x minus 2. So we got that y equals -4/3x minus 2/3. And we've got two equations again. This will be equation number 1, and this is equation number 2. And we will be needing more space, so I'm just going to rewrite it as we need to solve it simultaneous. We can just let y, well, equation 1 equals equation 2 because they're both in terms of just y equals. So we get that it is 1/4 x, so I'll write it here, 1/4 x minus 9/4 should equal a -4/3x minus 2/3. So remember, just so you don't get confused, I just took this equation and made it equal that equation. And now we can solve for x. So just finding the lowest common denominator, and I get that 3x minus 27, because you times both by 3 on this side, equals -16, because we have to times by 4, because the lowest common denominator is actually 12, x minus 8. And then we can move this x to the one side and move your constant to the other. So we get 3x plus 16x should equal -8 plus 27. And I get then 19x should equal it should equal 19. Divide both sides by 19, so you get x equals 1. And then going back again, we can choose any one. Let's just choose this first one. We have that y equals 1/4 x minus 9/4. And we can then substitute in for x, so y equals 1/4 1 minus 9/4. So we get that y equals, your calculator, -2. That's your midpoint. So we've got a y value, we've got our x value. So therefore, midpoint of AB is 1 and -2. And that's question 11 done. Quite a toughie. Before I go, I'd like to give a very special thank you to our epic sponsors for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorials. If you can't find the answer to your question, remember you can always send us your question and we will respond with a personalized video just for you. And until next time, stay epic.